Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math B4 Variant 3 October-November 2019. Let's get started. In a cycling club, the number of members are in the ratio males is to females equals 8:3. The club has 342 females. Find the total number of members. In our ratio setup, when we add 8 and 3, we get 11. We've been told the number of females is 342 and we want to find the total number of members. This is what we are calling X. From this, we can cross multiply and make X the subject. This gives us 11 times 342 divided by 3, which is equal to 1254. Find the percentage of the total number of members that are female. This percentage would be equal to the number of females, which is 342, divided by the total number of members, which is 1254 times 100%. When we type this into the calculator, we get 27.3% rounded to 3 significant figures. The price of a bicycle is $1,020. Club members receive a 15% discount on this price. Find how much a club member pays for this bicycle. Since the discounted price is a 15% reduction on the original price, we subtract 15% from 100%, which gives us 85%. And so the discounted price is equal to 85% of $1,020, which is equal to $867. In 2019, the membership fee of the cycling club is $79.50. This is 6% more than last year. Find the increase in the cost of the membership. If we represent the fee for last year with Y, then we have 106% of Y equals $79.50. When we make Y the subject, this is what we have. When we type this into the calculator, we get $75. Therefore, the increase will be $79.50 minus $75, which is equal to $4.50. Asif cycles a distance of 105 kilometers. On the first part of his journey, he cycles 60 kilometers in 2 hours 24 minutes. On the second part of his journey, he cycles 45 kilometers at 20 kilometers per hour. Find his average speed for the whole journey. The average speed for Asif's journey would be equal to the distance he traveled divided by the total time duration for the journey. The total time duration for the journey is equal to T1, which is the time duration for the first part of the journey, plus T2, which is the time duration for the second part of the journey. T1 has been given as 2 hours 24 minutes. To convert 24 minutes to hours, we divide by 60. 224 over 60 hours is the same as 2.4 hours. We can find T2 by dividing the distance for the second part of the journey, which is 45 kilometers, by the speed, which is 20 kilometers per hour. When we type this into the calculator, we get 2.25 hours. Hence, the average speed will now be 60 plus 45 kilometers divided by 2.4 plus 2.25 hours. When we type this into the calculator, we get 22.6 kilometers per hour. Brian invested $480 in an account 4 years ago. The account pays compound interest at a rate of 2.1% per year. Today, he uses some of the money in this account to buy a bicycle costing $430. Calculate how much money remains in his account. First, let's find the current value of his investments by applying the compound interest formula. Big A represents the current value of the investment, which is what we are finding. Small a represents the initial value of the investment, which is $480. R is the rate, which is 2.1%, and T is the time duration for the investment, which is 4 years. When we type this into the calculator, we get $521.61 rounded to 2 decimal places. After he buys the bicycle, the amount that remains in his account is $521.61 minus $430, which is equal to $91.61. The formula S equals half AT squared is used to calculate the distance S traveled by a bicycle. When A is 3 and T is 10, each correct to the nearest integer, calculate the lower bound of the distance S. When we correct 3 and 10 to the nearest integer, we bring plus and minus 1 and divide 1 by 2. To get the lower bound for S, we need the lower bound for A and T. The lower bound for A is 3 minus 1 over 2, which is equal to 2.5. And the lower bound for T is 10 minus 1 over 2, which is equal to 9.5. So now the lower bound for S will be half times 2.5 times 9.5 squared, which is equal to 112.8125. The diagram shows a triangle and a quadrilateral. All angles are in degrees. For the triangle, show that 3a plus 5b equals 170. The sum of the angles in the triangle should add up to 180 degrees. And so, a plus 2b plus 2a plus 3b plus 10 should be equal to 180. A plus 2a is 3a and 2b plus 3b is 5b. When we subtract 10 from both sides, we have 3a plus 5b equals 170. For the quadrilateral, show that 9a plus 7b equals 310. The sum of the angles in the quadrilateral should add up to 360 degrees. And so 8a plus 3a plus 2b plus 4b minus 2a plus b plus 50 should be equal to 360 degrees. 8a plus 3a minus 2a is 9a, and 2b plus 4b plus b is 7b. When we subtract 50 from both sides, we have 9a plus 7b equals 310. Solve these simultaneous equations. Show all your workings. Looking at the two equations, we can start by eliminating the variable a. So first, we multiply equation 1 by 3. This gives us 9a plus 15b equals 510. We can label this as equation 3. So now, when we subtract equation 2 from equation 3, this is what we have. 15b minus 7b is 8b. When we divide both sides by 8, we get b equals 25. To get the value of a, we can plug in the value of b in either of the equations. If we pick equation 1, we have 3a plus 5 times 25 equals 170. When we subtract 125 from both sides of the equation, this is what we get. When we divide both sides by 3, we have a equals 15. Find the size of the smallest angle in the triangle. If we plug in the values of a and b into the three angles in the triangle, we see that the smallest angle is 30 degrees. Solve the equation 6x minus 3 equals -12. When we add 3 to both sides of the equation, this is what we have. When we divide both sides by 6, we get x equals -1.5. Rearrange 2 times 4x minus y equals 5x minus 3 to make y the subject. When we expand the brackets, 2 times 4x is 8x and 2 times -y is -2y. From here, we rearrange the equation to leave 2y standing alone. 8x minus 5x is 3x. When we divide both sides by 2, we have y equals 3x plus 3 over 2. Simplify. 27x raised to the power 9, all raised to the power 2 over 3. By applying the laws of indices, this can be rewritten as 27 raised to the power 2 over 3 times x raised to the power 9, all raised to the power 2 over 3. 27 raised to the power 2 over 3 is 9. The powers of x multiply, and so 9 times 2 over 3 is 6. Our final answer becomes 9x raised to the power 6. Simplify. X squared plus 5x over x squared minus 25. For the numerator, when we factor out x, we are left with x plus 5. For the denominator, we have a difference of 2 squares, x squared minus 25, which can be rewritten as x squared minus 5 squared. When we apply the factorization for the difference of 2 squares, we have x plus 5 times x minus 5. X plus 5 cancels out, and so our final answer becomes x over x minus 5. The table shows some values for y equals x cubed plus x squared minus 5x. Complete the table. When we plug in x equals -1 into the equation, we get y equals 5. For x equals 1, we get y equals -3. And for x equals 3, we get y equals 21. On the grid, draw the graph of y equals x cubed plus x squared minus 5x. For x is greater than and equal to -3 and less than and equal to 3. So first, we plot all the points from the table on the grid. Then we connect the points with a smooth line. Use your graph to solve the equation x cubed plus x squared minus 5x equals 0. In other words, we need to find the x-coordinate of the intersection point between the curve and y equals 0, which is the x-axis. From the graph, we get these points as x equals -2.8, x equals 0, and x equals 1.8. By drawing a suitable tangent, find an estimate of the gradient of the curve at x equals 2. On the grid, we draw a tangent to the curve at x equals 2. Then we pick 2 points on the tangent to estimate the gradient. In this case, we are using the points 2, 2 and 2.5, 7.5. When we plug in these coordinates into the gradient formula, we have m equals 7.5 minus 2 divided by 2.5 minus 2. When we type this into the calculator, we get 11. Write down the largest value of the integer k so that the equation x cubed plus x squared minus 5x equals k has 3 solutions. For x is greater than and equal to -3 and less than and equal to 3. In other words, we need to find the line y equals k such that this line cuts the curve at 3 points. This value of k needs to be the largest integer. From the graph, we see that this line is y equals 6, and so the value of k is 6. The diagram shows a field ABCD on horizontal ground. There is a vertical post at C. From B, the angle of elevation of the top of the post is 19 degrees. Find the height of the post. From this illustration, we see that tan 19 degrees equals h over 107 meters. When we make h the subject, this is what we have. When we type this into the calculator, we get 36.8 meters rounded to 3 significant figures. Use the cosine rule to find angle BAC. When we apply the cosine rule to triangle ABC, this is what we get. When we make angle BAC the subject, this is what we have. From here, we plug in the values of BC, AB, and AC into the equation. When we type this into the calculator, we get 42.1 degrees rounded to 1 decimal place. Use the sine rule to find angle CAD. When we apply the sine rule to triangle ACD, this is what we have. When we make angle CAD the subject, this is what we get. When we type this into the calculator, we get 35.8 degrees rounded to 1 decimal place. Calculate the area of the field. The area of the field is equal to the area of triangle ABC plus the area of triangle ACD. When we apply this formula to each of the triangles, this is what we have. When we type this into the calculator, we get 9,670 meters squared rounded to 3 significant figures. The bearing of D from A is 70 degrees. Find the bearing of A from C. The bearing of A from C has been indicated with a blue arrow. We've been given the bearing of D from A as 70 degrees. And so to get this angle, we subtract 35.8 degrees from 70 degrees, which gives us 34.2 degrees. These two angles are interior angles. Interior angles add up to 180 degrees. And so when we subtract 34.2 degrees from 180 degrees, we get 145.8 degrees. And so the bearing will now be 360 degrees minus 145.8 degrees, which is equal to 214.2 degrees. The cumulative frequency diagram shows information about the distance d kilometers traveled by each of 60 male cyclists in one weekend. Use the cumulative frequency diagram to find an estimate of the median. To get the median, we map half of 60, which is 30, on the diagram. This gives us the median to be 52 kilometers. Find an estimate of the lower quartile. To get the lower quartile, we map 1/4 of 60, which is 15, on the diagram. This gives us the lower quartile to be 36 kilometers. Find an estimate of the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. We've already found the lower quartile in the previous question to be 36 kilometers. To get the upper quartile, we map 3/4 of 60, which is 45, on the diagram. This gives us the upper quartile to be 62 kilometers. And so 62 minus 36 kilometers gives us 26 kilometers. For the same weekend, the interquartile range for the distances traveled by a group of female cyclists is 40 kilometers. Make one comment comparing the distribution of the distances traveled by the males with the distribution of the distances traveled by the females. When we compare the interquartile range for the females, which is 40 kilometers, to the interquartile range of the males, which is 26 kilometers, we see that the females have a higher interquartile range compared to the males. Therefore, the distribution of their distances vary more. A male cyclist is chosen at random. Find the probability that he traveled more than 50 kilometers. This probability is equal to the number of male cyclists who traveled more than 50 kilometers divided by the total number of cyclists. When we map 50 kilometers on the diagram, we get 27, which represents the number of male cyclists who traveled 50 kilometers or less. And so to get the number of male cyclists who traveled more than 50 kilometers, we subtract 27 from 60. The total number of male cyclists is 60. When we type this into the calculator, we get 11 over 20. Use the cumulative frequency diagram to complete this frequency table. When we map 50 kilometers on the graph, we get 27. And when we map 60 kilometers, we get 41. 41 minus 27 is 14. When we map 60 kilometers, we get 41. When we map 70 kilometers, we get 53. 53 minus 41 is 12. When we map 70 kilometers, we get 53. When we map 90 kilometers, we get 58. 58 minus 53 is 5. Calculate an estimate for the mean distance traveled. The mean is equal to sigma f of x, which represents the total distance traveled by all the male cyclists, divided by sigma f, which is the total number of male cyclists. Before getting sigma f of x, we need to get an average distance for each of the distance intervals. So for the first interval, the average distance is 0 plus 40 divided by 2, which is 20. Then we have 40 plus 50 divided by 2, which is 45. 50 plus 60 divided by 2, which is 55. 60 plus 70 divided by 2, which is 65. 70 plus 90 divided by 2, which is 80. Then finally, we have 90 plus 120 divided by 2, which is 105. So for sigma f of x, we have 20 times 18 plus 45 times 9 plus 55 times 14 plus 65 times 12 plus 80 times 5 plus 105 times 2 kilometers divided by the number of male cyclists, which is 60. When we type this into the calculator, we get 48.75 kilometers. In the diagram, A, B, C, and D lie on the circle center O. Angle ADC is 128 degrees. Angle ACD is 28 degrees and angle BCO is 30 degrees. Show that obtuse angle AOC is 104 degrees. Give a reason for each step of your working. Chord AC subtends angle AOC at the center of the circle and subtends another angle ABC at the circumference of the circle. This means angle AOC is twice angle ABC. ABCD is a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral should add up to 180 degrees. And so angle ABC plus 128 degrees should be equal to 180 degrees. And so when we subtract 128 degrees from 180 degrees, we get angle ABC to be 52 degrees. So we have angle AOC equals 2 times 52 degrees, which is equal to 104 degrees. Find angle BAO. OA and OC are radii of the circle. This makes triangle AOC an isosceles triangle. Base angles in an isosceles triangle are equal, and so to get each of these angles, we subtract 104 from 180 and divide by 2 to get 38 degrees. The sum of the angles in triangle ABC must add up to 180 degrees. When we make angle BAO the subject, we get 22 degrees. Find angle ABD. Chord AD subtends an angle 28 degrees on the circumference of the circle and subtends angle ABD at another point on the circumference of the circle. This means angle ABD should also be equal to 28 degrees. The radius OC of the circle is 9.6 centimeters. Calculate the total perimeter of the sector OADC. The total perimeter of OADC is equal to OA plus OC plus arc ADC. OA is 9.6 centimeters and OC is also 9.6 centimeters. The length of the arc can be found using theta over 360 degrees times 2 pi r, where theta is 104 degrees and the radius r is 9.6 centimeters. When we type this into the calculator, we get 36.6 centimeters rounded to 3 significant figures. The diagram shows two mathematically similar solid metal prisms. The volume of the smaller prism is 648 centimeters cubed and the volume of the larger prism is 2187 centimeters cubed. The area of the cross-section of the smaller prism is 36 centimeters squared. Calculate the area of the cross-section of the larger prism. For similar shapes, we know that the ratio of their areas should be equal to the square of the ratio of their corresponding side lengths. We've not been given the ratio of their side lengths. However, we know that the ratio of their volumes should be equal to the cube of their corresponding side lengths. Since we are interested in finding the square of the ratio of their side lengths, we take the power of 2 over 3 to both sides of the equation, and this is what we have. So now we can say that the ratio of their areas is equal to the ratio of their volumes raised to the power 2 over 3. So now when we make the area of the bigger prism the subject of the equation and plug in the given values, this is what we get. When we type this into the calculator, we get 81 centimeters squared. The larger prism is melted down into a sphere. Calculate the radius of the sphere. We've been given the formula for the volume of a sphere. When we make R the subject, this is what we have. The volume V of the sphere is the same as the volume of the larger prism, which is 2187 centimeters cubed. When we type this into the calculator, we get 8.05 centimeters rounded to 3 significant figures. Describe fully the single transformation that maps shape A onto shape B. When we look at both shapes, we see that shape B is reflected about a mirror line, which is y equals -1. And so the full description for the transformation will be reflection in the line y equals -1. On the grid, draw the image of shape A after a translation by the vector -3, 4. For this translation, the translation vector dictates that we move each of the vertices of shape A 3 units to the left and 4 units upwards. On the diagram, the movement for point A has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of shape A. Draw the image of shape A after a rotation through 180 degrees about 0, 0. First, we mark the center of rotation, which is the origin. Then we rotate each of the vertices on shape A 180 degrees about this center. To pin the new position of point B, all we need to do is draw another line with the same length from the origin. After repeating the same process for all the other points as well, we are able to map out the rotated image of shape A. Draw the image of shape A after an enlargement, scale factor 2, center -7, 0. First, we need to mark the center of enlargement. Then we need to move each vertex on shape A such that we are able to reproduce the enlarged image of the shape. Let's pick point C. To move from the center of enlargement to point C, we move 1 unit up and 4 units to the right. The scale factor is +2, and so to pin the new position of point C, we move twice in the same direction. Initially, we moved 1 unit up. This means we are going to move 2 units up. And instead of moving 4 units to the right, we move 8 units to the right. After repeating the same process for all the vertices on shape A, we are now able to map out the enlarged image of shape A. A bag contains 4 red marbles and 2 yellow marbles. Bernas picks 2 marbles at random without replacement. Find the probability that the marbles are both red. This means we are finding the probability that the first marble picked is red and the second marble picked is also red. The probability that the first marble picked is red is equal to the number of red marbles in the bag, which is 4, divided by the total number of marbles, which is 6. Without replacement, the pool reduces by 1, and so the probability that the second marble picked is red will be 3/5. When we type this into the calculator, we get 0.4. Find the probability that the marbles are not both red. The sum of the probability that both marbles are red and the probability that both marbles are not red must add up to 1. And so to get the probability that both marbles are not red, we subtract 0.4 from 1, which is equal to 0.6. Another bag contains 5 blue marbles and 2 green marbles. Brain picks 1 marble at random without replacement. If this marble is not green, he picks another marble at random without replacement. He continues until he picks a green marble. Find the probability that he picks a green marble on his first, second, or third attempt. We have 3 possible scenarios in this case. In the first scenario, he takes out a green marble on the first pick. In the second scenario, he takes out a green marble on the second pick. And in the third scenario, he takes out a green marble on the third pick. The probability that he takes out a green marble on the first pick is the number of green marbles, which is 2, divided by the total number of marbles, which is 7. For the second scenario, the probability that he takes out a blue marble first is 5/7. Without replacement, the probability that he now takes out a green marble is 2/6. For the third scenario, the probability that he takes out a blue marble on the first pick is 5/7. Without replacement, the probability that he takes out a blue marble on the second pick is 4/6. Without replacement, the probability that he now takes out a green marble is 2/5. When we type this into the calculator, we get 5/7. Find f of 4. To get f of 4, we replace x in f of x with 4. This gives us 2 times 4 minus 3, which is equal to 5. Find h of g of 3. First, let's find g of 3. To get g of 3, we replace x in g of x with 3. This gives us 9 minus 3 squared, which is equal to 0. So now to get h of g of 3, we replace x in h of x with g of 3, which is 0. This gives us 3 raised to the power 0, which is equal to 1. Find g of 2x in its simplest form. To get g of 2x, we replace x in g of x with 2x. This gives us 9 minus 2x all squared. 2x squared is 4x squared, and so our final answer is 9 minus 4x squared. Find f of g of x in its simplest form. To get f of g of x, we replace x in f of x with g of x. This gives us 2 times 9 minus x squared minus 3. When we expand the brackets, 2 times 9 is 18, and 2 times negative x squared is negative 2x squared. 18 minus 3 is 15, and so our final answer is 15 minus 2x squared. Find f inverse of x. We know f of x is 2x minus 3. So in the first step, we replace f of x with x and replace x with y. When we make y the subject, this is what we have. This result we have for y is the same as f inverse of x, which means f inverse of x is also equal to x plus 3 over 2. Find x when 5 times f of x equals 3. F of x is 2x minus 3, so we have 5 times 2x minus 3 equals 3. When we expand the brackets, 5 times 2x is 10x, and 5 times negative 3 is negative 15. When we add 15 to both sides, this is what we have. When we divide both sides by 10, we get x equals 1.8. Solve the equation g of f of x equals negative 16. To get g of f of x, we replace x in g of x with f of x, which is 2x minus 3. When we expand 2x minus 3 all squared, we get 4x squared minus 12x plus 9. When we simplify this equation and group like terms, this is what we have. The terms have a common factor of 4, and so when we divide through the equation by 4, we get x squared minus 3x minus 4 equals 0. We can solve for x using factorization. We can rewrite negative 3x as x minus 4x. When we factor out x from the first two terms, we are left with x plus 1, and when we factor out negative 4 from the final two terms, we are left with x plus 1. This can be rewritten as x plus 1 times x minus 4 equals 0. When we equate x plus 1 to 0, we get x equals negative 1. And when we equate x minus 4 to 0, we get x equals 4. Find x when h inverse of x equals negative 2. To get h inverse of x, we replace h of x with x and replace x with y. Y is the same as h inverse of x, which has been given as negative 2. So we have x equals 3 raised to the power negative 2, which is equal to 1 over 9. Solve 1 over x minus 2 over x plus 1 equals 3. Show all your working and give your answers correct to 2 decimal places. When we multiply through the equation by x times x plus 1, this is what we get. When we expand the brackets on both sides of the equation, this is what we have. When we move all the terms to one side of the equation and group like terms, we get 3x squared plus 4x minus 1 equals 0. We can solve for x using the quadratic formula. So when we apply the quadratic formula to the equation, this is what we get. The numbers under the square root simplify to 28. For the denominator, 2 times 3 is 6. For the first possible value of x, we get 0.22 rounded to 2 decimal places. And for the second possible value of x, we get negative 1.55 rounded to 2 decimal places. OAB is a triangle and ABC and PQC are straight lines. P is the midpoint of OA. Q is the midpoint of PC, and OQ is to QB equals 3:1. OA is 4A and OB is 8B. Find in terms of A and or B in its simplest form, AB. AB can be expressed as AO plus OB. AO is minus 4A and OB is 8B. And so our final answer is negative 4A plus 8B. Find OQ. We were given the ratio OQ is to QB equals 3 is to 1. This means OQ is 3/4 of OB, which is 8B. 3 over 4 times 8B is 6B. Find PQ. PQ can be expressed as PO plus OQ. PO is negative 2A and OQ is 6B. And so our final answer is negative 2A plus 6B. By using vectors, find the ratio AB is to BC. First, let's find BC. BC can be expressed as BQ plus QC. BQ is negative 2B, and we found QC in the previous question to be negative 2A plus 6B. When we simplify this, we get negative 2A plus 4B. We found AB in part AI as negative 4A plus 8B, and we've just found BC to be negative 2A plus 4B. When we factor out 2 from negative 4A plus 8B, we are left with negative 2A plus 4B. When we compare this with BC, we get the ratio 2 is to 1. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.